Today, we'll be discussing on bakery product. Our start of the day is bread! We choose bread with wheat germ as a prototype of spoiled food because of a few elements. There are two characteristics of bread with wheat germ, which it is high in moisture content and high in carbohydrate. It contains 44.9 gram per 100 gram. Bread molds thrive on bread because of the rich organic materials found in it, and carbohydrate fuels the growth of mold spores. Wheat germ is a storehouse of minerals loaded with contents of vitamin E, protein, vitamin B1, B2, B6, magnesium, phosphorus, zinc, natural fiber, and omega-3 fatty acids. But why wheat germ? Wheat germ comes with a lot of health benefits, such as it has protein that builds and repairs body tissues, it has iron to promote red blood cell formation, it has vitamin B1 and B2 that support the release of energy. It contains calcium that develops strong bone and teeth. Wheat germ is also cholesterol-free and trans fat-free. But we should never forget about the one crucial factor that causes spoilage of bread, which is the water activity. Fungi can grow with water activity of 0.8. Cream cracker is also used in our experiment for comparison, as they have different characteristics and causes different spoilage patterns. For cream cracker, it is high in moisture content, high in fat, which is 26 gram per 100 gram, and high in carbohydrate, which is 61 gram per 100 gram. It contains a relative high proportion of fat compared to bread. They usually have longer shelf life. An open package of cracker can last for 6 to 9 months. An open package of cracker that's stored in container can last for 1 to 2 months for its best quality. So what is the type of food spoilage or poisoning in the viewpoint of microbiology and the microorganism involved? For bread with wheat germ, after 1 week, the type of food spoilage is moldy. In terms of poisoning, molds on the bread can cause allergic reaction and respiratory problems. Some molds will produce mycotoxins, poisonous substances that can cause sickness, which are nauseous and vomiting. The microorganisms involved are Penicillium and Aspergillus niger. On day 1 and day 2, the bread did not show any obvious changes in appearance. However, on day 3, a small part of mold started to grow at the right upper corner. On day 4, the mold continued to grow more on the right side. Starting from day 5, the mold has covered 50% of the area of the bread and 75% of the bread on day 6. On day 7, the mold has covered and spread almost 100% of the area of the bread.
On the other hand, for cream cracker, after 1 week, according to observation, it becomes softer and soggy as it absorbs moisture from the environment. It has rancid smell due to lipid oxidation because oxygen from the environment reacts with the fat on the cracker. It has no molds observed on the surface of the cracker. This might be due to the low moisture content and normally high in fat characteristics. Characteristics do not support the growth of microorganisms. Thus, the shelf life for cracker is the longest in most of the bakery products. The cracker does not show any physical changes from day 1 to day 7.
To be more specific in a scientific way, how do we detect or indicate this particular microorganism? The most common technique in detecting mold of fungi is the polymerase chain reaction (PCR) techniques. Real-time PCR techniques such as Solvent blotting and agarose gel electrophoresis are more preferable than the conventional ones, as they are fast enough to eliminate time-consuming techniques like microbiological techniques, more sensitive, and more accurate to analyze the reaction product. Secondary metabolite profiles, isozyme analysis, and molecular techniques were introduced to be as powerful tools for detecting and identifying fungi like Aspergillus and Penicillium species. Molds growth found on breads and other bakery products are commonly Aspergillus and Penicillium species, but based on the observation of the bread for 7 consecutive days, it can be somehow concluded that the species is more to be a Penicillium species. The penicillia of Penicillium species produce conidia from conidiospores that branch near the apex, forming a brush-like structure known as penicillus. The conidia of the penicillia are colored, mostly in the shades of gray to blue-green, which is what the color of the mold grown on the bread. Furthermore, it has a fuzzy appearance and will produce mycotoxin, which will make it as a potentially dangerous mold. They can produce a number of mycotoxins, such as ochratoxins, penicillic acid, trichothecins, fumonisins, and alpha-toxins. This image shows the simplest and most complex conidiophores produced by Penicillium species. To identify the specific groups of fungi, direct sequencing of PCR-amplified DNA using primers that are complementary to conserved sequence within the nuclear, mitochondrial ribosomal genes, and internal transcript spacer regions (ITS) were used. Among all of them, internal transcript spacer regions, as known as ITS, was favored for Penicillium species detection. Penicillium spinulosum, Penicillium roqueforti, Penicillium carnum, Penicillium verrucosum, Penicillium viridectum, and Penicillium aurantiogrisum are common Penicillium species found to be involved in bread industry. What are the most common sources of contamination and factors that affect the growth of microorganisms? Molds are able to convert nutrients into cell material and mycelial biomass. For instance, they may convert the carbohydrates and lipids to alcohol, organic acids, and complex heterocyclic biochemical compounds through secondary metabolism. This process was aided by the enzymes excreted from mold biomass to break the substrate down into available nutrients. Bread acts as a very suitable platform for the growth of fungi as it is high in both carbohydrates and lipids. These secondary metabolites accumulate in the bread and thus causing off flavors and odors. Mold growth are also affected by a number of factors, including moisture content, water activity, relative humidity, and temperature. All these factors are interrelated. The most important factor among all is the water activity, which accounts for the measure of the amount of water which is not bounded by the substrate and is available to microorganisms for growth. It is affected by relative humidity, RH, of the environment surrounding the substrate. The sample product, bread, was covered with a plastic bag, therefore it is not fully in contact with the environment, but still the air may diffuse through the bag, just the effect may be reduced. Apart from that, water activity is highly affected by moisture content. The higher the moisture content, the higher the water activity, and vice versa. Molds are able to grow in water activity with a range of 0.72 to 0.95, but will be completely inhibited at water activity below 0.65, equivalent to less than 20% of moisture content. Therefore, molds are able to grow on bread with a water activity of 0.95, but not on biscuits as the water activity is too low at 0.30. How about the temperature? Molds grow the best at temperature within 20 degrees Celsius to 37 degrees Celsius, and the optimum temperature will be 30 degrees Celsius, which is around room temperature. Extreme temperatures like too hot or too cold will inhibit or slow down the growth of mold. So, what can we do if we cannot finish eating them within a few days? So let me teach you how to preserve your food. Molds are aerobes, which requires oxygen for growth. Their growth can be inhibited by decreasing the concentrations or total eliminations of oxygen or increasing the concentrations of carbon dioxide or nitrogen. Preservation techniques such as controlled atmosphere packaging (CAP), modified atmosphere packaging (MAP), and vacuum packaging can be used to prevent deterioration caused by mold. Molds are not very heat resistant and they can be killed by most high temperature processes like cooking and baking. Refrigeration can be a preservation technique, but molds cannot be completely killed, but only the growth will be slowed down. Thus, it is recommended to heat food before consuming. Good sanitary conditions and cleaning practices should also be observed to reduce risk of contamination and ensure hygienic food.